I am Sharath Selgar, going to start this lecture on production economics. Okay. So today in the lecture, finally I will ask. So the screen is also coming, and I'm also audible, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah, sure. So yeah, these are the things which I'm going to cover today. I will be telling what is agriculture production economics, then what are different type of variables asked, production functions, what are different types, neoclassical production function, this I'll be taking little detail, isoquant and its properties, on this I'll be explaining most, and returns to scale, homogeneous production function, and finally I have multiple choice questions. And for the benefit of MSc and PhD students, I also included this Cobb-Douglas production function. But as I think already we have lost some 15 minutes, so I will leave the MCQs and the Cobb-Douglas for you to go through. Everything is drawn and derived in it, so it is just for practice. So yeah, I'm starting with agriculture production. So we know that here I am having two type of approach. One is that we definitions and other properties for the students to go later on with the presentation, and other things I'll be explaining mostly based on the exam purpose. So I'll be highlighting those points which are very important for exam purpose. Okay. So when it comes to agriculture production economics, two things are important. One is it is applied science. Secondly, it is applied to the farm level. Okay, so the objective here is to maximize the yield or minimize the cost of the farmer, ultimately to increase the net income of the farmer. So the second definition, that is, it may be defined as an applied field of science, wherein principle of economic choice are applied to the use of resources of land, labor, capital, and management in farming industry. So the things are applied science, then to the farming industry. So when these two will come, it is about production economics. So there are so many goals of production economics. Like we would like to assist farm managers in determining what are the values, what are the goals, and to assist policymakers to come up with the better policies. Then to evaluate the theory, that what are different concepts we are giving, are they really increasing the yield or are they increasing profit or not, that we can evaluate. Then different technical and institutional changes, like we come up with new machineries, new enterprise relationships. So what are its effects? Similarly, we can also see how an individual level we can see what are the minor changes and how it is affecting farm resource, like it is being referred directly to partial budgeting. Okay. Now, here it's classification of variables. Variables are of three types: decision variable, predetermined variable, uncertain variable. These three variables are classified based on whether the researcher or the user has knowledge on it and whether he has control on it. When he has the knowledge as well as the control, then that we term as decision variable. For example, how much seeds we want. Okay. The second thing is he has the knowledge but no control. That is called predetermined variable. Like rainfall. We know that rainfall may come, we know what its effect, but we don't have any control on it. Third, we have uncertain variable, where we have no knowledge also, where it is not in our control also. Maybe some, like how this COVID pandemic was there. This was completely unaware. Okay. So what are the different factors of production? We know land, labor, capital, and organization. So what we should see is some of the key terms in its definition. Like when we say anything free gift of nature, it refers to land. I'm telling again objective point of view. If they give gift of nature, then it is land. So, and land does not specifically mean it literally meaning. Land refers to soil also, forest also, water also, minerals also. Okay. And what is got for land? It is rent. So for land, it will be rent. For labor, it will be wage. For capital, it will be interest. And for entrepreneurship, it will be profit. Fine. So when it comes to land, it is free gift of nature. It is indestructible. No two pieces of land are similar. Fine. And land is productive only with the efforts of labor. So all these are properties of land. Then comes labor. Labor is any physical or mental contribution of a human being taken for the monetary purpose. or any other purpose other than pleasure. So these terms are labor. You can find these definitions in any of the standard books, but I'm highlighting those keywords. Any mental or physical effort which has been done by the human for any other reason other than just pleasure. Okay, that we call labor. Means he should take some salary or wages. That is the labor. So labor is inseparable from laborer. So labor is inseparable from laborer. This sentence will be asked in exams. So make note of it. Then we have capital. See, capital and organization are produced means of factors. Okay, and other two are original factors of production. So capital is a wealth which is used for further production. So wealth which produces wealth is known as capital. So if you have money, that money only which you will invest in some business is capital, not all the money. If you are keeping some money stock in the bank, then that is not the capital. So remember one thing, wealth is not the capital. Only the part of wealth which you invest in the business is capital. So the statement is all capital is wealth, but all wealth is not capital. Okay, these sentence may come in JRF also, SRF also. So I'm telling. Then entrepreneurship. Entrepreneurship main point is they have two roles. One is organizing, other thing is risk bearing. So here it is there, that ability and action to take risk of collecting, coordinating, utilizing all the factors of production. Means, to put in simple terms, organizing and risk taking. For this, entrepreneurship will be there. Okay, and what you will get instead, you will get profits. So there are different concepts of productions. Okay, like total product, average product, marginal product, and elasticity of production. So what is my total product? It refers to the total volume. Okay, so we can take the formula as average product into labor. And or if we do summation of marginal product, then also we get total product. So in exam, they may give one of the equations of like this is the marginal product or this is the average product. They may ask total product, or usually they will give total product and they will ask you to derive marginal product, where we have to do simple differentiation of one step. Okay, and one more important unpopular question is they will ask d by dx of e raised to x. The answer will be e raised to x. Then we have average product. Then we have marginal product. So marginal product is that output which is obtained by the additional unit of input. That change in output is called marginal product. Fine. So that is dq by dl. Then elasticity of production. Elasticity production of is measure of degree of responsiveness. These three terms you should remember. Measures of degree of responsiveness. Whenever this will come, it is referring to the concept of elasticity. So in exam, they may not ask directly elasticity, but if this term degree of responsiveness will come, then elasticity we have to measure. So measures of degree of elasticity of response between output and input. And the one more popular question is, what is the measurement of elasticity of substitution? Elasticity of substitution or elasticity of production has no units. Fine. So that is one of its advantages, because both denominator and numerator and denominator will be having same units. It get cancelled. So we have no unit for elasticity of production or substitution. And this formula EPP is equal to MPP by APP is one of the important formula. Sometimes we get confused with MPP and APP. So the code what I keep is MA. So M will come up, A will down. So I think that is the only thing where you can get little confused, especially for BSc students who are applying for a JRF. Okay. Then we this elasticity of production in three classical stages. Initially, it will be more than one in first stage. It will be less than one in second stage, which is rational stage. And third, it will be less than 0, where MPP will also be negative. Then comes concept of time. Concept of time was given by Alfred Marshall, And the important question for objective exam is market period. In market period, which force determines the price? So it is given here that supply is fixed. So what will determine price is demand. So whenever supply is fixed, that is called short term or market period to be perfect. In market period, only demand will influence the price, supply will not influence the price. Second is short run, means it is little longer than market period. Here supply can be changed, but the plant size cannot be changed. That within the existing plant size, you can increase or decrease the supply. That is short run. Then we have long run. Long run is plant size can be changed. Okay, but technology remains nearly same. But in secular period, I request them to mute. Praveen, you can mute because I'm using this one.
Yes.
In secular period, technology can be changed, population can be changed. Means we have four factors: price of the product, price of other product, taste and preference, and technology. This taste and preference and technology, these two factors can be varied only in secular period. In other three periods, these two will be constant. Okay. So remember these four terms. These terms are very popularly used, but we have to know what they exactly mean. And the book given by Alfred Marshall, the famous book is Principles of Economics. So which book, which person gave, at least for the four definitions of economics, we should remember. Then we have law of variable proportion. So you might be thinking why this came suddenly. We classify the terms as short term and long term. So short term, we deal with law of variable proportion, and in long term, we deal with returns to scale. Okay. So short term, in one more definition, is that at least one of the factors should be fixed. You cannot keep everything variable. When at least one factor is fixed, then that term is called short term, or you can say short term production. When all the factors are variable, then we term it as long term production. So when we keep at least one of the resource fixed, we change one resource and we see that the output is changing with changing input, then that relationship is called as law of variable proportion. Okay, so I repeat, with at least one factor fixed, when we are changing input, the way output changes with changing input is defined or explained by the law of variable proportion. We tell it as law of variable proportion because the proportion between output and input goes on changing. That is why we call it as law of variable proportion. Am I clear? So this is the graph explaining for law of variable proportion. Most important graph, and I'm sure that in all the exams, 2 to 3 questions will be coming from this graph. So I'll be telling the different locations where this graph questions will come. So I think you people are able to see the graph. Okay. So we have y-axis, we have x-axis. Now the questions may be like, what is the shape of TPP curve up to the point of inflection? It is concave. Okay. Then from concave it will become convex. Fine. No, I mean, starting it will be convex and then it will become concave. Whenever we are defining the shape of the curve, we are referring with respect to the x-axis. Fine. So this is first question. Second, when MPP is more, means MPP is highest, that point on TPP is called as point of inflection. There's one more point called as point of satiation. That is when MPP is 0, means the point M, which I have defined in graph, is point of satiation. And the point where MPP is maximum is point of inflection. Inflection means the changing curvature. Okay. So they may ask this, and one more. When MPP is increasing, it is greater than APP always. This they ask always. Whenever MPP is increasing, it is always greater than APP. Next question comes. When MPP is decreasing, it is always greater than APP. No, that is not the point. Because even in first stage, when MPP is decreasing, till the end of first stage, MPP is more than APP. So don't think just by drawing 3 lines, the graph is completed. No, they may ask different questions from each single stages. Like they may ask what is elasticity of production in each stage. In first stage, it is EP is more than 1. In second stage, EP is less than 1. And third stage, EP is negative. Why EP is negative? Because their marginal product is negative. Okay. We know that EP is equal to MPP by APP. When MP is negative, obviously, and AP will always be positive. So EP will be negative. Fine. And until unless AP is increasing, MPP will always remain above APP. So these relations, if you are not able to remember, at least make sure that you remember this graph clearly. So you can draw this graph exactly in a short period in that exam, and you can make sure what he is trying to ask. Okay. If there is any other doubts, they can ask for this graph. Shall I move ahead, or any person wants to ask anything? And in first stage, MPP is TPP is increasing at increasing rate, then constant rate, then start increasing at decreasing rate, and then starts declining at increasing rate. Okay. So all this is about, I have told in brief, but in slides it is there in future, in further slides it is there. So there you can refer for studies. Okay. Now coming to long-run production function, which we call it as returns to scale. So what is returns to scale here? The major difference between law of variable proportion and returns to scale is, in law of variable proportion, at least one of the input is fixed. That is, it is short term. But in returns to scale, all the inputs are varied simultaneously. Then we study if we simultaneously means together. When all the inputs are changing simultaneously, how the output is changing? That function or that relationship is termed as returns to scale. Fine. So I have again made classification between these two in a table, so that you can use for exam purpose. But to explanation, I'm telling, in both the law of variable proportion and returns to scale, we are studying how output is changing with respect to input. But in first one, that is in law of variable proportion, one of the input is fixed. So we are seeing how the output is changing with changing in one of the inputs. But in returns to scale, all the inputs are changing, and we are studying what is the relationship between the output and the input. I hope I have explained and repeated. So I think now it might be known to you. Okay, so here are the all explanation for law of variable proportion. As I said, I have given you for the reference. So this all I have explained till now. So what is, how it is changing, what is the definition to be written in exam. Okay. I also explained why it is called law of variable proportion, because it will go on changing. So I have taken a numerical example so you can understand that. So the question is that suppose in the beginning 10 acres of land and 1 unit of labor are taken for the production. Hence land labor ratio is 10:1. But we go on increasing labor by 1 unit, and this output will be changing by other units. Like when we increase to 2, it may become 5, it may become 10 again. Means the output has not increased, only input increased. So from 10 and 1, it will become 10 and 2. So 10 divided by 2 is 5. So the land labor ratio is 5. So I have taken it. Okay. So since it analyzes the effects of change in factor proportion, it is called as law of variable proportion. So this is the table for the first one. Okay. So starting, you can see it is increasing, then it is constant, and finally it is decreasing. So this is how we have to do. And I already gave formulas in the beginning. So you can see the change in TPP, like 2 minus 0 divided by MPP, it is 1. So 2 by 1 is 1. Similarly, all are there, okay? So this is the diagram. As those who felt that the first diagram is not clear, they can refer here also. Fine. So these are the, what I'm telling, the different avenues for the questions which may come. So instead of reading them separately, when you draw a graph and try to point out all these characteristics in the graph, okay, that is the only feasible solution to read all these characteristics. Draw a graph and do this, okay? And this all I explained, like TPP is increasing, and in first stage MPP will always be increasing, and in third stage MPP will always be decreasing. In second stage MPP will be decreasing, but it will be more than 0. Okay, so all these things are there. So you can refer to the table and you can go through in detail with each point. So reasons for operation of law, yes, the reasons are like there are different factors are there, okay? So they are not perfect substitutes. So it goes on changing, and few are fixed and few are variable. That is why the effect will also be changing. So these are the reasons why it is increasing or decreasing. And to be very specific, the two main causes for changing variables or changing variable to proportion or changing interest to scale is, first one is indivisibility, and second is manageability. So when we start, if you start a class, if you have some 5 to 10 students, then the efficiency of teacher is more than that of for the students. When it increases to 10 to 20, then that efficiency may be correct, exactly correct. But if class strength increases more than 20, then teacher may not be able to concentrate on every student. Okay. So why? Because here managerial ability will come, first thing. Second, the what is it? Indivisibility of the items will be there. For example, starting if only a few tables, few chairs will be there. So one person can sit in one. Then one more person can come and sit in the same. It's okay. But how when more and more people increase, we can't increase the physical inputs. Remember, this is short term. So we can't change the plant size. Due to these two terms or these two reasons, there will be variable proportion. Returns to scale. I have explained the definition. The important line is to remember that all the variables simultaneously in the same magnitude change. Because if you're increasing x1 by land by some unit and labor by some unit and capital by some unit, and then if you want to study its the relationship with output, means it is not possible. So land, labor, capital all will be increased by 2 or 1 units, and then we study how the output is changing. Okay, so equal and simultaneous change in all the factors is returns to scale. So these are definitions and explanation. So same how I gave one numerical for law of variable proportion, here also I have given. Now here you can see initially it is increasing like 100 to 250. The increase is 150. Then from 250 to 600, increase is 350. Okay. So from 150 to 350 it has increased. So it is increasing returns to scale. Increasing means what? You are increasing the inputs by 1 unit, but output is increasing by more than 1 unit. Then that is what we call increasing returns to scale. Then we can see the increase is 600, 600. Because 600 to 1200, and then 1200 to 2400. Okay. So then what we see, the increase is decreasing. That is, the amount is going on decreasing. So this is what we call increasing returns to scale and decreasing returns to scale. And the major graphical question which may come is there are two ways of explaining returns to scale. Okay, so this I have given the tabular analysis for it. See, this graph shows increasing constant and decreasing returns to scale. Okay. Now, here you can see down inputs will be there and here output is there on the y-axis. The same graph can also be explained by like this. I have taken all the three ways of explaining returns to scale in these 3 slides. This is the first way. Okay. First way of showing returns to scale. This is the second way. This portion AB is straight line for us in this diagram, but this AB is convex when it is increasing returns to scale. So the most popular question is the shape of the curve in increasing returns to scale, decreasing returns to scale, and constant returns to scale. So these are the 3 graphs. Now the same relationship can also be shown like this. And what is the difference here? This relationship is a relationship between an input and the output. That is, here we are studying input-output relationship. Okay. In this graph, we have both inputs. So the line which we have got, A, B, C, D, those are isoquants. So when you want to define returns to scale using isoquants, this is the diagram. Here, the distance between the isoquants will tell you what is returns to scale. If the distance between successive isoquants is decreasing, then we call it as increasing returns to scale. If the distance between consecutive isoquants is constant, then it is constant returns to scale. And if the distance between the isoquants is declining, if it is increasing, then it is called decreasing returns to scale. Okay. So we have input and output measurements also. We can see that output is increasing at the constant rate, that is 10 units, 50 to 60, 60 to 70, 70 to 80, like that. But the inputs required for it is increasing. Initially, we took only 56 to 64, that is 8 units. So 8 units of capital was required starting. Then again 6 units. Okay. So first we wanted 8 units, then we wanted 6 units. 6 why? Because 64 to 70 capital has increased. You see y-axis. Okay. So initially we wanted 8 units, then we wanted 6 units. So here the units of input required to produce the same output is decreasing. That is, its efficiency is increasing. Efficiency is nothing but returns to scale. So don't understand either in 2 ways. One is the closer the isoquants, increasing returns to scale. If isoquants are moving away from each other, then decreasing returns to scale. Okay. And you can also see mathematically by taking capital and labor units. Okay. That you can calculate and see again. So I have sent division of labor and volume discounts. Volume discounts means manager capability as 2 of the causes for operation of returns to scale, as well as law of variable proportion. So these are again 3 favorite statements for the exam to ask: economics and diseconomics. Okay. So they ask like, when economics exceed diseconomics, we have increasing returns to scale. When economics and diseconomics are equal, we have constant returns to scale. And when diseconomics exceed, it is diminishing returns to scale. Okay. So these are the difference between law of variable proportion and returns to scale. Okay. So students can go through this table for writing answers between variable and returns to scale. But briefly, I will tell, law of variable factor is short-term for short-term production function. Returns to scale is for long-run production function. For variable factor, we have only few quantities variable. For returns to scale, we should take all the factors as variable. Okay. Then there is no change in scale of production, but here there is change in scale of production. Okay. Yeah. Now coming to isoquants. So isoquants is one of the favorite topics for the examiners, most important topic, because anyone will think that a student who is coming from agriculture economics background should know this isoquant concepts completely. So before starting this concept, I want to know whether I was clear in the initial slides, or I need to explain something. Is there anything in chat box? Praveen, is there any question in chat box? Any doubts?
No, sir. It's fine.
Okay. So only there are two conclusions. Either everything is being understood or everything is going above the head. So I suppose that everything is being understood.
Yeah, I request to participant. If someone has any query regarding this session, please ask.
Yeah, they can unmute and speak because from here it is difficult for me to access chat box.
Yeah.
Because starting concept, whatever I thought, they are definite to come in exam. There's no exam that you can't tell that it may or may not come. It will definitely come.
And point of exam, sir, it is one of the most important topics. So I
Yeah.
request to all the participants, if someone has any query regarding this chapter or session, please ask to sir. Okay, sir, I think no query. You can.
Okay. So I'll continue. Okay. So
Okay.
isoquants is there. Now the definition of isoquant. What is isoquant? See, if we try to by heart definition, it may again get confused because there are so many definitions: isoquant, isocline, ridge line, scale line. Okay. So just try to draw the isoquant and then try to define the isoquant. Like I can't draw here because using mobile, but try to understand. We are taking two input axes. Okay. We are taking two axes where inputs are there. Then we draw a curve, which we call it as isoquant. So what we are telling, it is the locus of points showing the combination of factors producing a given level of output with given technology. Because one isoquant shows that what are the different combination of the inputs to produce a given level of output. Okay. That is why isoquant is also known as isoproduct curve. Because one isoquant determines one level of output. Now coming to the slope of isoquant. One slope of isoquant gives us MRTS, marginal rate of technical substitution. Slope of isoquant gives us MRTS. Slope of this production function, this PPC curve, gives us MRPS. Okay. So we should remember that. And what is the equilibrium point? As yesterday I said, we have to see what is the statement, what are the tools, what is the equilibrium point, and what are the critics. Okay. So isoquant usually have no critics because it is a tool, it is not a theory. So the equilibrium point for the factor production, where we use isoquant concept, is marginal rate of technical substitution is equal to the inverse price ratio. We tell it as inverse price ratio because if we take MRTS X1, X2, okay, here it is actually MRTS X2, X1. So if we have, like I'm showing you next slide, if we have MRTS X2, X1, then it is equal to minus dy dx2 by dx1 is equal to px2 by px1. So it is inverse relationship. We are taking the below segment upon above segment. That is it. That's why we call it inverse ratio of the prices. Okay. Actually, I had a formula here to explain how to answer this question. So I can't use the pointer and all, but I'll try to explain. Please give little concentration, because if you understand this formula will help you to attend these questions very immediately. The code is topper, capital T, small a, capital P, small r. Fine. Yesterday I told you that the one which will come in numerator is replaced resource and one which will come in denominator is added resource. I hope you remember. See, I told you, if we are having dx2 by dx1, then x2 is replaced resource, x1 is added resource. Okay. So whenever MRTS is more than price ratio, we increase added resource. And whenever MRPS is more than price ratio, we increase replaced resource. So they will ask among these two, there are 4 combinations, and in these 4 combinations, they may ask any one single question. So either you understand this formula technically, and okay, MRTS is more than price ratio. So if you want to bring it to equilibrium, should we increase X1 or X2? Like that, you understand? No, sir, for JRF students who are they were unable to understand this mathematically, remember this formula. If MRTS X2 X1 is more than PX2 by PX1, then it is beneficial for the organizer or businessman or farmer to increase the use of X1. So not X1, X2, because X2 is the added resource. X1 is the replaced resource. You can see graph also. X2 is being added, X1 is being replaced. Okay. So this formula is understood. This is definite question. And most of the people do wrong here. Fine. So when we know that a certain question is going to come in exam, then we should not make wrong in that, and then we should not even spend more time on that. Okay. So I assume that everyone has understood. I give 1 minute pause. If anyone is did not understand, can ask again. Fine. I assume that it is being understood. Then we are coming to type of isoquants. There are different type of isoquants like linear isoquant, right angle isoquant, kink isoquant, and convex isoquant. For JRF point of view, right and convex is very important. And linear isoquant, they will ask the here, how are the factor substitution? Factors are perfectly substitute in case of linear isoquant. For MSc students and PhD students, kink isoquant is very important. Kink isoquant, the demand curve, which is kink in the shape in the oligopoly competition. Okay. There we use kink isoquant. So those are preparing for ARS and SRF, they concentrate on kink isoquant. For JRF, they will may not ask kink isoquant. Okay. So you may go for linear and convex. So try to give importance differentiating for the different topics. Don't try to become master of all the topics. Okay. So this is linear isoquant. Linear isoquant means what? We can go for a produce by any combination of inputs. There are infinite combinations of inputs. Capital and labor can be taken in any combinations to produce the output. This is exactly opposite in right angle isoquant. Right angle isoquant is also known as Leon-Schiff isoquant. This is a popular question. Okay. How to remember Leon-Schiff? L is there. L is nothing but right angle. So here we are taking, it is inverse L here. So don't try to find L in the diagram. So this isoquant is L and it is right angle. That is, there's only one combination in which capital and labor have to be mixed up to produce the output. Fine. Remember one thing. When we are drawing Leon-Schiff or right angle isoquant, our shape is inverted L shape. But when we are drawing right angle production possibility curve, then that is exactly L shape. It is not inverted L shape. So if question is asked, what is the shape of right angle isoquant, then it is inverse L shape. There will be both options, inverse L shape and L shape. And if the shape is asked for production possibility curve or product to product curve or iso resource curve, then that is L shape. Okay. Then is kink isoquant. Kink isoquant is also known as activity analysis program isoquant. because it is used in engineering. Okay, they refer to it as activity analysis, and it's also known as linear programming isoquant. Hmm. So the key term in King isoquant is limited substitutability. Understand this. Unlimited substitutability or indefinite substitutability is in the case of linear isoquant. Only one combination is possible in right angle. Limited number of combinations. Okay, like there are 4 points here. At 4 points only, it can combine. It can give kink isoquant. Fine. So when we have limited number of substitutability between factors of production, that we see kinks at those points, and hence it is called as kink isoquant. Kink means what? Bent structure. Okay. So usually a line will be straight, but if it is bent somewhere, then we say at the bent point it is kink. Then we have convex isoquant. So what is, see, first we told n number of combinations, linear. Only one combination, right angle. Limited number of combinations, kink isoquant. Then what is convex? In convex, we have smooth, continuous substitutability between two products. And the important point is, as we go down, as we move along the curve, the substitutability decreases. That is why we say isoquant is always convex. See, there are two properties of isoquant. One is it is declining. It has negative slope. That is, if you increase one input, you have to decrease other output because level of output is same. Okay. If we have one box and if you have two items to keep, like one may be chocolate and one may be biscuit. If you want to increase biscuits, then you have to reduce chocolate because box size is same. So when slope is negative, if one factor is decreasing, other factor is increasing. This I told in yesterday also. Okay. But when we say isoquant is convex, we are trying to mention that as we move down, then the substitutability is decreasing. Fine. So this is isoquant curve. So the properties of isoquant. Here two properties are explained. One is negatively slope, which I told that one is increasing, other should decrease. See, if you see from point A, B, C, and D, here X is decreasing. No, X is increasing and Y is decreasing. Okay. Then convexity. This also I told. And I have told the two reasons why it is reducing. One is each want is satiable. Second is they are imperfect substitutes. Then third is they cannot intersect. Why cannot intersect? Simple point. One isoquant tells you one level of output. So if two isoquants are intersecting, means there are two levels of output intersecting at one point. It cannot become, see, here IQ1 is showing 200, IQ2 is showing 100. Then at point A, it is neither 100 nor 200. Okay. And this is inconsistent with the theory. So isoquants never intersect. Higher the isoquant, here's the higher output level. Obviously, if we increase a combination of inputs, output will be maximum. Now here, when we speak about traditional theory, we refer to an convex isoquant which is asymptomatic to the input axis. Asymptomatic means what? It is not touching x-axis or y-axis. Okay. So I'm not telling that isoquants will never touch x-axis or y-axis, but in traditional theory, which is more popular, it will not touch the input axis. But when you read different production functions, okay, so they will be going quadratic production functions, and there are so many other production functions like quadratic, Spillman, okay, then cubic, even in Cobb-Douglas production functions, if you see, they are touching the axis. Okay. So that is what I'm telling. For as a normally you understand that isoquant will not touch x-axis. This for JRF students. For SRF and ARS, you remember that the shape of isoquant is the function of production function form. The shape of isoquant is function of the production form. If production is linear production function, the shape is changing. If it is quadratic production function, shape is changing. Okay. So this question was asked. So I'm telling you that the shape of isoquant is influenced by the form of production function. Now coming to the final topic. This is called homogeneous production function. Very popular, but very simple. Homogeneous production function means what? I'm telling in simple words. So if we are increasing inputs by a constant multiple, say we are doubling it, okay, and output also doubles, then we say it is homogeneous production function of degree 1. Okay. Now if we are increasing inputs by double and output increases by 4 times, then we tell it is increasing, it is homogeneous production function of degree 2, because 2 square is 4. So when it comes to definition, we should write like this, that if the inputs or factors are increased by an independent variable which is constant, when we multiply the independent variables by a constant called lambda, then the dependent variable, that is output, changes by lambda raised to n, where n is known as degree of homogeneity. As I said, if output also doubles, because input is doubling, then n is 1. If input increases 2 times and output increases 4 times, then n is 2. Okay. So if you are able to take out the factor lambda out of the output, then we tell it as homogeneous production function. So definition I have given, how the formula I have given, okay. And one important bit for SRF students is CES production function, constant elasticity of substitution production function, which is homogeneous production function of degree 1, qualifies for the Euler's theorem. I repeat, the question will be which of the production function qualifies for Euler's theorem? It is constant elasticity of substitution. Why? Because there are 2 needs for Euler's theorem. One is it should be homogeneous production function. Other is its degree should be 1. So homogeneous production function of degree 1 qualifies for the Euler's theorem. Okay. What is Euler's theorem? Euler's theorem is if we provide every factor equal to its marginal product, then the total product is completely exhausted. That is not required for other students, so I haven't mentioned. But I'm giving a path for the other students that they can go more into this homogeneous production function. Okay. So in homogeneous production function, this lambda, a constant, which is multiplied to the inputs, can be taken out from the output. And one important bit for the JRF as well as FSAF student is homogeneous production function of degree 1 is nothing but the constant returns to scale. I repeat, homogeneous production function of degree 1 is nothing but constant returns to scale. And yeah, even more important question for JRF and SRF is the summation of elasticity coefficients in the Cobb-Douglas production function gives us returns to scale. So when you have Cobb-Douglas production function, when we calculate its exponential coefficients, when we add it, we get returns to scale, and they individually show elasticity of production. So what I'm guiding you is, when you are preparing for exam, kindly go through Cobb-Douglas production function completely. Cobb-Douglas production function, the questions will be elasticity of production, then returns to scale, and what is its elasticity of substitution. elasticity of substitution for Cobb-Douglas production function is always equal to 1. And elasticity of production of CES is always constant and not 1. It may be 1 or may not be 1, but it is constant. Okay. That's why we say that Cobb-Douglas production function is a limiting factor of CS production function. These things, when they come in exam, it looks like very difficult, but we understand the concept, then they are not where they are very simple riddle-like questions. So try to understand the concepts. Okay. So here I have given some MCQs. So students can go through them. I have also given answers. So yeah, there are some other questions also which I have hinted for the SRF students. This is the way how they ask for the SRF and ARS net exams. Okay. Direct questions from production economics. So we have to understand the things, and at least production functions and other things should be read at least 8 to 10 times. Then only we can understand the difference between production functions, or else after closing the book, from linear production function to the translog production function, everything looks the same. Okay. So in a production function, what we should know? We should know what is its functional form. We should know what are the power of its variable. What is its isoquant look like? How it is production curve look like? What is marginal product? What is
खुद का ICAR का ये कर रहा हूँ।
ये भाई पूरे मजे ले रहे हैं। What is marginal product? What is average product? What is elasticity of production? What is elasticity of substitution? Okay. What are the limitations? What are the applications of production function? These everything should be known of the production function, and the best reference book for production functions as per se is Sankhyan book. Sankhyan book is best for production functions. And when we want to read agriculture production economics, then VT Raju is best book. Okay. So instead of only depending upon Subbareddy book for agriculture production, this VT Raju is completely specified into it. Okay. So for JRF people, VT Raju is sufficient. With VT Raju, you also try to understand Cobb-Douglas. Cobb-Douglas is the only function they will ask in JRF. So I have given Cobb-Douglas in the end of these slides. They can go through. Second, for SRF and ARS exams, you have to go through all these production functions, especially quadratic production function and Cobb-Douglas production function. Okay. Because these two are very popular. Cobb-Douglas is popular because it is very simple, and some elasticity of production directly available. There are some factors. And quadratic is important because it is mostly used in agriculture. Okay, or this fertilizer response mechanism and all, we can read it from quadratic. So these are some questions. And then these are some bits. Okay. We have it for students. We usually, when we take classes, in classes at the end of the things, we give bits like memory champs. These memory champs are those terms which have come at least in 3 papers in previous 10 or 5 years. Okay. Once they come 3 times in previous 5 times, it means that they are most frequently asked questions. And then we make its bits and we give to students, so that if these questions will come, there should not be even more than 2 seconds a student is wasting on it. Okay. So they will ask who gave law of minimum. It is Justin von Liebig. So there is no need of thinking about it. Okay. Like that. Slope of ridgeline 0 to infinity. Okay. So this is Cobb-Douglas production function. So I have derived it and I have given. Okay. So MS students as well as other students can go through. For the benefit of BSc students, I will explain a little bit. See, don't try to understand everything. It is above your scope. But just because examiners are trying to sometimes ask, okay, I'm telling you, y is equal to a0, x1 raised to a1, x2 raised to a2, so on to xn raised to an. It means that x1, x2, x3 are the variables. a1, a2, an are the coefficient of those variables. So just remember, BSc students, that A1, A2, A3 are the elasticity of production of the factors. If they ask you what is the elasticity of production of X1, it is simply A1. Nothing you need to explain. What is elasticity of production of X2? It is simply A2. Okay. And what is returns to scale? A1 plus A2 plus so on to AN is returns to scale. If A1 plus A2 is 1, then it is constant returns to scale. If A1 plus A2 is less than 1, like 0.5, 0.6, then it is decreasing returns to scale. And if it is more than 1, it is increasing returns to scale. For net exam, this simple numerical problem is compulsory. They will give this and they expect you to add A1 plus A2 plus A3 and know whether it is more than 1 or less than 1. And so tell it whether it is increasing or decreasing returns to scale. Okay. So they may also give functional form and they may ask you to derive AP and MP, but that is only for SF and PhD students. Okay. So that's why, and what I said is elasticity of production. See, I have derived elasticity of production is nothing but A1. Similarly, elasticity of substitution is 1. That also I have derived as C. Elasticity of substitution, the whole derivation, and then it will come yes, 1. Okay. So if someone is writing mains exam, then kindly make sure that for every production function, means even in future, if you write ARS mains exam, for every production function, you should write production function. It's AP, MP, EP, okay, and RTS. That is enough. You need not to try everything. But for Cobb-Douglas and linear production function, they may ask to write all the characteristics. But for other things, they will ask only till AP, MP, and elasticity of production. Okay. So thank you. If there are any queries, they may ask. Details are already shared yesterday. Okay. So I also sent the today's and yesterday's lectures to Praveen. So he will be sharing the host. He'll be sharing with you, and in there also last slide is there. So I was very happy to see so many feedbacks yesterday. I hope that it will also help you. And again, I'm sorry for initial technical problem. So I hope I have tried to do my best to reach you people. Okay. So thank you. And Praveen, let me know if students want something and I can help
yes,
in
sir.
any other manner for
Definitely,
this.
sir. Okay, again, I would like to request all participants, if someone has any query, please stop. The topic is open for discussion now.
Sir, can you send your material for us, sir?
Yeah. Already I told morning session, ma'am. The university has restricted to share on group. So after completed all our program, I will try my best. So and each and every one, I will share.
And one more thing, sir. Actually, some people is not admitted in this group, sir. I got a link from other teacher, and then I'm going to join, sir. So I request again, can you join please me in your group, sir?
Yeah, okay, ma'am.
Okay, thank you.
Please Prasan
Praveen,
send me number. Yes, sir.
I have heard that
Yes, sir.
this program is for all the students. It is even it is being
Yeah.
publicized for others also, right? Then I
Yes.
think it should be shared, because see, if it is for only MPKV students, then fine. But what I have heard, I don't know exactly, that some teachers told that it's open for all the students, and they'll be
Yeah.
going to upload it on YouTube also. So you
Yeah.
can do. And
But what happened, sir? Actually, from yesterday, sir, university net has been collapsed, so there is
no problem.
connectivity problem. Yeah, that's
Yeah,
why.
no problem. See, materials will be coming to you. Yeah, the madam
Yeah.
who asked. You can also put mail to me, or you can put on WhatsApp message. I will mail you also. I already have mailed to 2 3 students who asked. So don't worry about material, you will get.
Yes,
But
sir.
please,
After completing all sessions,
yeah.
yes, sir.
So may I know
Yeah,
the
sir.
girl
After
who?
completing all sessions,
Yeah,
that is a yeah, sir. After 10 March, I will send to all of you,
yeah.
all participants.
Yeah. My doubt is the girl who asked this. For which exam are you preparing?
Ma'am.
Hello, the madam who just asked material now. May I ask her to tell for which exam she is preparing? I can suggest the material as per that exam. That's why. Hello. Okay, so I presume that if they are preparing for JRF, then it's better that you go for a VT Raju book. And if you're preparing for ARS and SRF, try to go for a Sankyan book also. Hmm. And for any other doubts also, if you have, or if you want some extra guidance, then you can also join to this Agri Toppers classes. There also, the toppers will be there who will be explaining you, okay?
Hello, sir. How to join this classes, sir, of Agri Toppers?
See, you can go to the website and you can identify. Link will be there. You have to put your name and other college details, and you have to register yourself. Or you
Okay,
can
thank you,
WhatsApp
sir.
me after the class. So
Okay, sir.
I think you have my number from yesterday's class.
Yes, yes, yes. I got your number.
Yeah, yeah. So you can do it. Okay. Yeah,
Okay, thank you so much, sir. Thank you, sir.
yeah, yeah. It's my pleasure. See, I want to tell that in the concept of in economics, yeah, in economics, everything depends upon how many times you read a book. The same graph, the same concept, the same paragraph which we read, because it is economics, the way we interpret also matters. Okay. You might have seen this law of variable proportion before also, returns to scale before also, isocons before also, but you may not be gone to this depth. Okay. So the more number of times you visit it, the more number of times you will understand it. Or else join to something where teachers will explain you everything. Okay. So for who is preparing for JRF and other exams, see the major thing assumed is the student is preparing for these exams on his their own interest. Okay. University will not. It is very good that MPKV is taking what initiative in this thing, but usually even in our universities they think that student is preparing for JRF or ARS. It is his headache. He should prepare for him. They will help you just to understand the concepts and their exams, which curricular exams. For other national competitive exams, it is you to prepare with more depth, and you can also take the guidance from others. Okay. Yeah. Any other thing? Any other student want to know any other things? For material, I have said that okay. I will now again tell my number. You can note down my number and you can put message. I will send material because I understand that Praveen is not handling only one class. They are taking so many. So for him, it may be difficult to share, or he may have to wait for net. But for me, if there are less students, I can share. Okay. So my phone number is 9717 I repeat 9717 And my email ID is that easy. My name Sharat Yeligar. Everything is @gmail.com. SHARATHYELIGAR. Sharat Yeligar @gmail.com. So I think that exam is on the way. So anytime applications may also come. So it's better to start prepare. Any other doubts, Praveen? Any other students
Yeah.
have they asked anything in chat box?
No, sir, no.
Okay.
It's okay, sir.
Yeah, yeah.
Okay, and special thank to you and your part, sir, and make it very easy for today's lecture. And I hope all the participants get it easy, and it will definitely help for their upcoming examination like ICR net, not only for ICR net, but all competitive exam related to economics. Thank you so much, sir. And also I would like to thank our participant also because of their patience, because many time we have from yesterday also we have faced many technical issues. So thank you so much for them also. And also I request all the participants, please join tomorrow's morning session where our expert who is I think Jay Prakash sir who is from ICR, Indian National Rice Research Institute, who is the scientist who will be joined at 10:30 for tomorrow's session. So I would like to request all participants, please join
Yeah, and one more
at
thing.
10:30
Uh,
tomorrow morning. Okay,
yeah,
if someone
one
has
more
any
thing.
doubt or
Oh, yeah,
yes, sir.
the Jaiprakash sir will be taking class tomorrow. He is my senior in IRI, and what I know is he's very
Yeah,
good.
yes.
He's very good in his
Yeah,
explanation skills. Okay,
yeah.
so even he has guided us also.
Oh, yes, sir.
So I do suggest the students not to miss his class. I can assure you that once if you visit his class, then you need not to read the topic again from any other things. Okay, so that is how he is, and his writing skills are also very good. So we may ask about that also on personal chat for him, that how to write answers. But he is an excellent person, excellent in writing skills and explanation. Means his presentation is so good. We write same things, but the way he writes, he fetches more marks. So I request students to make use of that session. Okay. Yeah. Thank you.
Yes.
Thank you.
Thank you to
Thank you
all.
so
I
much.
declare that today's session is ended. Okay, thank you so much.